Alright, so welcome everyone. So we are going to learn the network flow problems. So what are we going to learn over here in this network flow problems? So the main objective is to finding a feasible flows through a flow network that obtain the maximum possible flow rate. That means you want to find in the graph what is the maximum flow. So before you want to find our objective to learn how to find the maximum flow, of course you need to learn the few fundamental keyword. So the first thing that you need to learn will be one, you need to know what is a capacity. What do you understand about the keyword capacity? And second, how to identify the maximum flow for a path. And third one, what is a cut, or how to find the capacity for the cut. And number 4, there's one theorem over here. You need to remember the theorem, which is maximum flow same as minimum cut. And last one, number 5, then you only will know how to identify the maximum flow based on just now what I mentioned over here. Our objective is to find the maximum flow. After you learn 1, 2, 3, and 4, then at the end you only know how to find maximum flow. So let's start over here. So this section we will explore project network. That means we still will explore a directed graph in terms of flow. So the flow network is a directed graph where the edges show the directions and the capacity of flow between the start, the source, and the end, sink. A flow network can be used to model traffic in a road system, fluid in a pipe, current in an electric circuit, or any situation in which something travels through a network of a node. So basically over here, once you learn this one, we can identify what is the maximum capacity for each of the path. So let's look at the diagram over here, this diagram. So in this diagram, what you need to know is we are trying to look at what is the value over here. Let's say this is your directed graph. In your directed graph, first thing you need to identify is where is the starting point or where is the ending point. Or to be more precise, I want to know which one is referred to the source, which one is the sink. So your question A, why A will be a source over here? Because you only have all the direction to the other sections. That means A, I'm going to B, A, I'm going to D, A, I'm going to C. That means you have an outflow over here for the A. And for F over here, that means your flow will be stopped at the town. So here we mentioned will be the sink. And what is this value represent? All this number. So all this number 300, 400, 400 over here is the flow capacity in liter per minute. That means here is represent the capacity value. So what is a capacity over here? My question is. So what is a capacity? I need to really tell you that this capacity is referred to the maximum amount that something can contain. So capacity means a maximum amount. That means over here, VE only able to carry 400 liter per minute. Maximum is 400 per minute. BE cannot go more than that. So that is means by capacity. So in this 4.05, you need to learn what is a capacity. Remember the definition of the capacity, maximum amount that something can contain. So next one. You need to learn these 3 keywords over here. What it means by inflow capacity, outflow capacity, maximum flow. So let's say, let's go into see one by one. So inflow capacity. So inflow capacity, not nice. Inflow capacity is a total flow capacity entering a vortex. Total flow capacity. So let's look at the question over here. Inflow capacity at vertex B. So where is vertex B? Vertex B is over here. So how many capacity going into B? 600 lah. From A to B only have one edges. So you write here 600. And what is the unit? Liter per minute. You need to write the unit. If you not, you're going to minus mark. Okay, next one. Look at what is outflow capacity. So outflow capacity is the total flow capacity leaving the vertex. So let's look at this question. Outflow capacity at vertex B. So your vertex B is over here. How many flow going out from B? In is 600, out is 300. So 300 liter per minute. And last one. What is the maximum flow out of vertex B? Okay. So what is maximum flow? So maximum flow, that is maximum flow, is the smallest of total inflow capacity and total outflow capacity. That means maximum flow will be the smallest value between inflow and outflow. So that means between inflow and outflow, you always choose the smallest value. That means that is the capacity for the vertex B. So look at the inflow. Inflow for B, you have 600. Outflow, you have 300. That means this B only can in 300 liter per minute. That's why you need to choose the minimum value, because capacity means the maximum capacity. Even though B, I say I can enter 600, but I only can come out 300. So that means over here, my maximum flow for B will be 300. So let's try one more question over here. How about E? Inflow for the vertex E. So how many capacity at the vertex E going into E? So using 300 plus 400 plus 100. So total is 800 liter per minute. Next one. So what is the outflow capacity at vertex E? So how many going out to E? Over here lah, 400. So it's 400 liter per minute. And at the end, what is the maximum flow? Only at that particular vertex. So the maximum flow will be between the smallest value, for the inflow and outflow will be 400 liter per minute. So you already know what is the capacity, how to find inflow, outflow for only one vertex and maximum flow for one vertex. So let's look at the example. So example 12, the network show the flow capacity in liter per minute. So please highlight the unit over here, because if not, you forget to write the unit. Okay, next one. Determine the inflow capacity for the vertex B. So my B over here, how many total going into the B? So only is one line, which is 150. So I write here 150 liter per minute. And question B, the outflow capacity of the vertex B. So how many flow going out from B? Over here. So from B, how many going out? 100. So it's 100 liter per minute. Don't write short form. Okay, question C. The maximum flow out of vertex B. So what is the maximum flow? So maximum flow at that vertex is, you have inflow 150, outflow 100. Choose the smallest value, 100 only. Even though you say you have 150 coming in, but you only can come out 100. That is the capacity. The maximum vertex B can contain, maximum amount. So let's look at question D. The maximum flow out of vertex C. Okay, right now check C. C is over here. So what is the maximum flow for C? you have inflow 200, you have outflow 300. You can in 200, you can out 300, but you only can in 200 over here. So that's why even though you go out, you only can go out 200. So the maximum flow is just 200 liter per minute. And for question E, the maximum flow out of vertex D. So vertex D is over here. So what is the maximum flow? You have inflow 350, outflow 250. So always the smallest value, 250 liters per minute. Alright, so if you have any question, please jot down. So next one, I will continue to the card and how to find the card and identify the capacity of a card as well. Alright, so you can move on to the next video.